Greetings everyone, this is non-expert here back again with another video. Today we are going to be solving problem number 10 of the 30 LeetCode challenge, and the problem which has been given to us is the min stack problem. We have solved this problem before, so this should be a relatively short video, but let's just go through the problem description. So we need to design a stack that's supposed to push, pop, top, and retrieving the minimum element in constant time. So basically we have all these functions which we need to implement or integrate inside our stack class, and we need to implement them in O1 of time. There are no restrictions which have been given to us regarding space or how the stack needs to be structured, so we'll be leveraging that. Inside your push, pop, top, and get min, let's just think about how we can represent a stack. In Python, a stack can be represented as a list. And a list already has an append operation which is similar to your push, a pop operation which is similar to your pop, and top can be represented as simply fetching the last value which is there inside your list. A get min is the only thing that we need to be aware of, and since we cannot iterate over all the elements inside our list, then what we can do is we can make sure that inside the nodes, inside each element inside a list, we can also contain the minimum value that we've encountered so far. If we do that, in essence, what's going to happen is that whenever we pop something out, well, whenever we pop something out, the value is going to get popped out. And if it was the minimum value, that's still fine because the next value would contain the minimum which was encountered at that time when it was pushed. So that's basically the intuition behind how this thing goes. I know it's getting a little tricky to understand what's happening, but let's just dive right into the code and you'll understand what's going on. So in essence, whenever we're doing a push, we need to make sure that we're going to be pushing a node instead of just pushing in the X value which has been given to us. And the node is going to be represented as a list. And I'm just going to make this, it can be anything that you want. It can be a dictionary, it can be whatever you want, but I'm just going to make it a simple list where the zeroth index value or the first element is going to be the X value, and the second element is going to be the minimum that has been encountered at that particular moment of time. Pretty straightforward, but the way we're going to be implementing the solution is we're going to start with the getMin function. And we're going to say that it should return a really large value if there's nothing inside our self.stack. And if there is something inside our self.stack, what we need to do is fetch the last value, which can be simply, we can fetch that with using -1. So when you do self.stack, which is a list, and you get -1, that returns the last value. And then that should return this node, which is basically a list. And we need to fetch the minimum value over here. So the minimum can be fetched by just doing 1. And a similar operation over here for the top as well. But instead of returning 1, we need to return 0 because that's where the X value resides under. And -1 if there's nothing inside the self.stack. Now, a pop operation is pretty straightforward. You just need to do self.stack.pop. There's not much there. Lists already handle that for us, so they pop out the last element. And all we need to take care of is the push now. So the reason why I did float infinity is because I'm going to be leveraging the getMin function. So what I'm going to do is I'm going to fetch, or rather, I'm going to see what's the minimum between X or self.getMin. In essence, what's going to happen over here is that if X is actually minimum than whatever is the minimum presently, then that is going to be set as _min. And now all I need to do is I just need to do self.stack.append and append in the list the node elements that we sort of conjured so far. So let's just do X_min. So basically, in essence, self.stack is going to be a list of lists, but overall you can fetch all the values as you sort of go about your operations. So let's just go ahead and run this. Hopefully this should run fine. And still running, and awesome, it ran fine. Let's go ahead and submit this. Until that's happening, let's just talk a little bit about how it's going to run for our case. So you have -2, which is going to be pushed inside your stack. So you have -2 first, then you have 0, and then you have -3. So a get min over here, as you can see, is going to be -3. But what happens when you pop out -3? Well, when you pop out -3, what's going to happen is then at the top you're going to have 0, but inside 0, since 0 is not less than -2, there's going to be one more element which is going to be placed inside over here, which is going to be -2, and that -2 is what's going to be the minimum, and the top is going to be the 0 value. And you can see that the solution is accepted, so awesome. That's basically it for today's video. If there's something you didn't understand, you can check out the link given in the description below, which should have the YouTube video where I go more into how this thing really works. But this is a pretty straightforward problem, and if you try to follow my approach, I think this becomes a really easy problem. But that's it. If there's nothing that you were not able to understand, then that's awesome. But if there's something you didn't understand, then do leave it in the comment section below. And if you did like this video, do give a like and do subscribe to our channel. We are a discussion over here, and we would love to have you on board with us. Thank you and have an awesome day.